Okay, so what we've done so far covered chapter 9, right? So part C is entirely chapter 8, the way it is stated here, okay, in this question. So look at this. It says a classmate suggested that the sample size in part A is small and that the sample mean of the collected data will not yield precise estimates of the population mean. And that is true. Whenever the sample size is small, the sample mean will not yield the same thing that will appropriately represent what you have in the population. Okay. This classmate also suggests that the standard error will be bigger than what one would expect with more data. And we also talked about this sometime in class. I remember one of you responded correctly to this question. Yes, so this will also be true. Whenever the sample size is small, the standard error tends to be bigger, okay? So it says there is probability that this may change conclusion reached at part A or part B, and that is very true, okay? But another classmate disagrees with all this, okay? And you all decide, two of you decide to compute the same statistics. Compute some statistics. Statistics are just the mean, median, mode, standard deviation, all these things we are computing are general statistics, okay? So all of you decide to compute some statistics to get a sense of the validity of the argument on either side of those two classmates. Okay, use only data from when a patch is placed over the right eye. So pay attention to that. We're using data from when a patch is placed over the right eye and not any other one, okay? And we're using alpha of 0.05 for this part of the question. So these two things changed. So let's go ahead and pick up the data for right eye only. So let's pick this again. We'll paste it and crop off the left eye. Excuse me. So let's put that down here. Paste it and kind of crop up the left to not to confuse us. Can I try do that? And the crop tool will be used here. Seems it can be used. Okay, so let's strike off the left. So we don't need this. Draw. Okay, so I'm going to draw here, pick up our right tool, and then we are crossing off this one. We don't need this. The question says use the data for only when the patch is placed on the right hand side to answer the question in this section. The idea thing we're going to do the two and then conduct the hypothesis testing to decide how this argument comes out. But this is just testing knowledge. So we know that if you can do for only one side, you are able to do for the second side. So we're going to focus on only the right side. Okay. So the first question says here, what is the point estimate for the population mean? And I'm giving you a hint here. We didn't say this in class, explain this way in class. So I'm giving you a hint here to account for that or to accommodate that. So this is another way of asking for the sample mean. So when somebody requests for the point estimate of the population mean, the person is simply asking you to compute the sample mean. So we're going to compute the sample mean here of this question. So the point estimate will be the mean for these people on the right tail. That will be the sum of all the data as usual divided by how many they are. So here we have 49 plus 47 plus 44 plus 46 divided by 4 because we have 4 data points. And I think we've done this somewhere else. So in this question, I don't really expect you to begin to work everything again, right? You've already done this somewhere. So just go up there and pick it up. So but I'm just going to complete this one since we started it. And for the rest, we start picking up the value whenever it occurs. So this is 49 plus 47 plus 44 plus 46. This will be 186. So 186 divided by 4. Remember, we have this value, 46.5. Okay, we already did this in part 1, right? Let's move up there quickly. Okay, we already did this in part 1, and I think even part 2, or rather part 2 really. We did that in part 2, and we got the answer here, right? 46.5. So whenever you're solving these problems and you are required to use something that you've already gotten before, just go up and pick it up. That saves you time, right? And also saves you from making mistakes. And that is if the first one was done correctly. Okay, so we have this value here. And the next question says compute the standard deviation. So I think we've also done this before. So we're just going to pick up what the value is over there and put it down here as our answer. Standard deviation for group 1, and we did that in part 2. Standard deviation for group 1 is 2.0817. So I'm just going to write that down, 2.0817. So we'll come over here, and we said our standard deviation is our standard deviation here for those in the right, using the right eye was covered, is 2.0187. Let me be sure that is what we have actually. 2.0817. So that is it. Okay, we continue. The next question says here, what is the significant level for the computation you and your classmates are about to make? The significant level is something as alpha. And in this question, we are told alpha is 0.05. So our significant level is 0.05. So there's really nothing to work here. So this is kind of testing whether you understand the concepts. What is significant level? And of course, maybe the explanation. So the significant level here is 0.05. That's what we are using. And the next question says, what is the appropriate test statistic? What is the appropriate critical value associated with this significant level? So the critical value associated with significant level, so we're going back now to chapter 7. Okay, the critical value could be a Z or a T critical value. But in this test, we conducted a T, right? A T test, because we just have 4 data points and we don't know the population standard deviation. So we conducted a T test. So we are looking for T critical value. Okay, so going back to chapter 7, that is how we computed our critical value. So I see here that I need to divide alpha by 2. Okay. So over here, we know that alpha is 0. So that alpha over 2, we know that alpha is 0.05. So if I divide alpha by 2, I'm going to get 0.025, I believe. Okay, so 0.05 divided by 2 is that, 0.025. So now to get my T critical value, this will imply T alpha over 2. I'm going to go to the table to look for that value. Okay, but I'm going to go to the T table, right? So this is our T alpha over 2. I'm going to go to the T table to get that value. So if you go to the table, find out this area in between and find out the T value that is equivalent, right? So I'm going to look for the area where I have 0.025. I'm going to look for this under the degree of freedom, which is n minus 1, the degree of freedom of 3 minus 1, 4 minus 1, which is 3. Okay, so I'm going to look for degree of freedom 3 and the area 0.025 in the T table. That is 3. Okay, so let's go to our T table now. I don't know if I have one. So let me go to the course website. I think we have one over there. Very quickly. So go to the course website. Let's see if we can pick up a T there. I think it should be what we did, the normal distribution, maybe confidence interval. So let's check this section. This is the normal table. The T table should be somewhere there. Okay, this is 6. Thought we had that in the same section. This is binomial really. Okay. Section 5. Okay, so let me go to section 6. What is 6? The central limit theorem. Okay, so maybe I didn't post that table here, but I thought I did. I think I will have to include that. Let me do that immediately. So you can have that as well. Choose a file. Okay, let's see. I have the T table. No, it's not there in this folder. It should be in GA. Let's go back a little bit. It should be here. Okay, I think it's here. So I will set T table. Okay, now you have it. Let's update that. Okay, so under this normal table, we also have the T table. So let's open that up. Okay, so the T table here, we are looking for, remember, two tail, right? This is alpha over 2, so we're looking for two tail. So pay attention to that. So this is two tail. Whenever you're calculating critical value, you use two tail. Okay? We're looking for two tail where you have 0.025 and degree of freedom of 3. Okay, so let's go back to the T table. So all this was done back in chapter 7. So we go to two tail, right? And we're looking for the area where we have 0.025, right, under two tails. So here we have 0.02, 0.01, sorry. So this is what it should be, right? We divided alpha by 2, so we have 0.025, right? So under one tail is where you're going to look for, because you divided alpha by 2. The whole of alpha is two tail, which would have been 0.05, right? So let me go back here and make that a bit clearer. So over here, we are conducting a two-tail test, remember? So we divide, alpha is your two-tail test, and alpha was given as 0.05, right? Alpha is given as 0.05. Okay, alpha is given as 0.05, right? But if you end up dividing alpha by 2, then you're making it one tail, which gives us 0.025, 0.025, right? Okay, so if you're looking for 0.025, that will be under one tail, but if you're looking for 0.05, that will be under two. Okay, so let's go back to that table. So going back to the table, so under this, both of them appear the same place, right? And we're going to look at the degree of freedom 3. So come over here. So this is actually the value of interest, is this one here, right? Let's color it yellow. Okay, so 3.182 is my T test, my critical value here, right? My T critical value. So our T critical value, and let's write it in full. The critical value right, which is for T alpha over 2, is given as the value I have there, which is 3.182. So I have 3.182. Okay. So this is the answer for that. Okay, so I'm going to go ahead and do the appropriate confidence interval. Oh, the appropriate. So this question says, what is the appropriate confidence level? Okay. The confidence level will be 1 minus alpha, right? We did this under chapter 7, remember that. So our confidence level here will be 1 minus 0.05, right? And this is equal to 95, 0.95. Okay, so essentially our confidence level is 95%. That's confidence level we are using for this calculation, given the alpha that we got. Now I say calculate the standard error, okay? And I emphasized this last class, and I'm gonna do that again here. And I will do that very quickly in a different page for the 3 different test statistics. Okay, so if we have one sample, the test statistics, so generally speaking, let me put this way, standard error, test statistics is defined as difference in mean divided by standard error. Not standard deviation, standard error. Okay, standard error is standard deviation divided by square root of n for one sample, and we're going to kind of illustrate that. And we also do that for paired and for independent sample. So for one sample, our standard error, I'm going to be using SE, okay? Let me write it in full and then abbreviate it. Our standard error is equal to standard deviation, sample standard deviation divided by square root of n, right? And that is why for t-test, when you have one sample, you see that the t-test here for one sample was given as the difference in mean, right? So X bar, you only have one sample minus the population mean divided by the standard error. And the standard error is S all over square root of n. Okay, so that is the formula for t-test statistics for one sample. For 2 samples that are matched, okay, for 2 samples that are matched, because they are matched, we are using standard deviation of the difference. The standard error for 2 samples that are matched is standard deviation of the difference divided by square root of n. Okay, and that is why the test statistics for matched pair let me write that differently. That is why the t-test for matched pair is equal to the difference. Remember the general formula, the general way of writing test statistics, the difference in mean divided by standard error. So that is why this one is written as the difference in mean. So XD bar, if you like, you could subtract this. We know this end up being 0 all over standard deviation of the difference all over square root of n. Right? So always you're dividing the difference in mean by their standard deviation. Difference in mean divided by standard deviation. That is how divided by standard error. Sorry, difference in mean divided by standard error is how you get your test statistics always. Okay, so let's do for independent sample. Okay. So 2 independent sample. Okay. Or we can say 2 samples that are independent. I think you understand what we mean. So the standard error here will be equal to, because they are independent, is the standard deviation for the first group, right? Excuse me, divided by square root of n for the first group, plus standard deviation for the second group divided by square root of n for the second group, right? So this is where it is, but this is not the way you find it in the test statistics. So let's convert it to that form. If you decide to, for example, take the, another way to rewrite this, and let me just write it and then I'll explain that. Another way to write this is just, okay, if I square everything here, right? Excuse me. Yeah, so if I square everything here, what will it look like? If I raise everything to power of 2, what will it look like? Or rather, if I take the square root of everything, what would that be like if I put a square root over here? Okay, so let me write it down and then I'll explain because it's going to become confusing. So if, for example, I decide to square everything, then it will look like this. Okay, for group 1, all over, I'm taking the square of the square roots. Okay. Okay, so I think this explanation will make it long. Let me write down the formula and then I will explain from the formula why they are the same. So instead of writing it this way, I can actually decide to say, okay, let me do this way. Take the square root of the square of group 1 divided by n1 plus the square of group 2 divided by n2. Okay, so these two are technically the same. Yeah, so this item here, let me use red. This item here is technically the same with this item here, right? They are the same thing because if you take the square root of the square, you're going to get S1, right? So if you take the square root of the square of 2, you're going to get 2. But the square root of the square of 2 is something like square root of 4, it will give you 2, right? So if you take the square root of the square of this value here, you're going to get this one back. If you take the square root of this one here, you're going to get this one back. And then you don't want to take the square root of the denominator, so just leave the square root back on the denominator, right? So this is the one, this second one is the one we have in the test statistics for independent sampling. So let's write it down. Let's go back to black. So for independent sample, the t-test is giving us the difference in mean, group 1, all over the standard error, which is written in this form, the variance, right? The square of the standard deviation is the variance. So the variance are divided by n1, or you can say standard deviation square for group 1 and standard deviation squared for group 2. That's why the test statistics is like this. Okay, so you see this is a pattern. Okay, so I hope that helps. So let's go back to continue our question now. Finish it up, it's almost completed. So the standard error here which is SE, the standard error, is giving us, we're dealing with one sample, remember, so this will be standard deviation divided by square root of n, okay? So we already got our standard deviation and we have it here as, where is that? We have it here as 2.0187. So here we just have 2.0187 divided by square root of n, and n is 4, right? So our standard error here will be 2.0187 divided by square root of 4, which is 2. So I have 1.0094. So that's our standard error. Let's go over to the next one. If you were to compute confidence interval here, what is the margin of error? So this is going back again to chapter 7. And if you recall correctly, the margin of error will be equal to T alpha over 2 times the standard error. Okay. We may not have used it separately this way in that space. So this will be equal to T alpha over 2. In this instance, it will be standard deviation divided by square root of m. So if you go back to 7, that's what you find that we use for margin of error when we are computing confidence interval. Okay, and so that's what we have here. Quickly simplify that. We already have all these components. We have T alpha over 2, which is our critical value. And the critical value here was 3.182. So I'm going to put that down. 3.182 times the standard error, which is 1.0094. Okay, so this will be our margin of error. Okay, so let's multiply these two very quickly. 3.182 times 1.0094. That gives us 3.2119, the 4 digits. Okay, let's do that again to be sure. 3.182 times 1.0094. That is 3.2119. Okay, that's what we have as our margin of error. And you can run this up to 2 digits if you want for a final answer. So this is approximately 3.2121 to the small. Okay. Compute the confidence interval. Now you've got every piece you need, right? So we know that the confidence interval is the same as the mean plus the margin of error. Okay, if you go back to chapter 7, you're going to find your slide with all these. Mean plus the margin of error on the lower part, and the mean minus on the lower part, and the mean plus the margin of error on the upper part. So the mean minus margin of error on the lower part, and the mean plus margin of error on the upper part. Okay. So if we simplify this, of course, we are going to get that the confidence interval will be equal to the mean. The sample mean here we got as 46.5. So we have 46.5 minus the margin of error, which is 3.21 on the lower part, and the upper part we have 46.5 plus the margin of error 3.21. Okay, and if we simplify this, we have that the confidence interval will be equal to so you have 46.5 minus 3.21, that gives you 43.29, and then you also have the same thing, 46.5 plus 3.21, that gives us 49.71. Okay. All right, so there's an interpretation we are going to give to this, but I wouldn't be asking you for that right now. We'll be able to interpret the confidence interval to show that it matches some conclusion when you reject or fail to reject in our next section when we use SPSS.